Yeah. Problem. 3-point charges are placed at the following points on the x-axis. 2 microcoulomb at x equal to 0. Okay. I'll take here the position x as a 0. Here we placed the first charge, that is 2 microcoulomb. And 3 microcoulomb, minus 3 microcoulomb at x equal to 40 centimeter. Along the same line, okay, at the distance of 40 centimeter, here, the second charge is placed, that is minus 3 microcoulomb. This is of 40 centimeter distance. And the third charge, it is at minus 5 microcoulomb. Okay, this is, I can take it as a Q3 minus 5 microcoulomb, and it is at the distance of 120 centimeter. Okay, so 120 centimeter is from the initial point. Got it? Here is the distance 40 centimeter, the distance between the Q1 and Q2, but the distance between the first charge and the last charge is 120 centimeter. Okay. Then what is the distance between the Q2 and Q3? It is 120 minus 40. So here it becomes 80 centimeter, right? First, we have to convert the sentence into picture. Then half of your problems get solved. So you can see your Q1 is positively charged plus 2 microcoulomb, but this is minus 3 microcoulomb. So of course there is an attraction because this is a plus and this is minus, right? So there is an attraction. So that attractive force will be, see, between the charge 1 and 2, I'll call it as a F12. Okay, it will attract. And next, there is a one more force that is from the third charge. Okay, observe the 2 and 3 both are negatively charged, negative, negative. There is a repulsion, right? So that repulsive force also acting in this direction. So F 2, 3. Observe here. So the net force acting at the charge Q2. Okay. So one is a F12 and one is the force from the third charge, F23. Due to the repulsion, the force direction is coming towards left only. And again, due to the attraction here in between them, again, the force acting towards left. Got it? So the net moment of this charge is towards left only. So let us find out first one by one. What is F12 and what is F23? To find out F12, that means force between the charge 1 and 2. Use the Coulomb's law. Q1 and Q2 divided by the R square. It is, okay, the distance between the first two charge. Okay. So I can call this one as a R1. R1 square, that is 40 centimeter. F12 is equal to 9 into 10 power 9. Q1, 2 microcoulomb. Q2, 3 microcoulomb. See, even though there is a negative sign, while substituting in the Coulomb's law, take it as a positive because we are considering magnitude of the charges. Whole divided by R1 square, the distance between them, it is 40 centimeter. I can write it as a 40 into 10 power minus 2, the whole square. Therefore, F12 becomes, solve this one, 6 and 9, and 6 are 54 into 10 power minus 12 and plus 9 minus 3 whole divided by 600. Okay, after squaring 600 into 10 power minus 4, so that I can write it as a 0.16. So solve this, you will get F12 as 337.5 into 10 power minus 3 Newton. Okay, this is the attractive force it is. I found the F12. Next, I have to find the F32. Observe, what is the F23 or F32? It is a force between the charge 2 and 3. Now I can use the same formula, but take the charge as a 3 and 5. And the distance between them is 80 centimeter. You can call it as a R2 distance. Okay, let's find out now. F23. And F23 is equal to 1 by 4 pi epsilon naught charge Q2 Q3 divided by R2 square. Substitute the value 9 into 10 power 9. The Q2 value 3 microcoulomb. Q3 value 5 microcoulomb. And the R2 80 centimeter. 80 centimeter. F23 is equal to, solve this one. 3 5s are 15, 59 are get 135 into 10 power minus 3. And this is 6400 into 10 power minus 4. You can write it as a 0.64. After solving, we get 211 into 10 power minus 3 Newton. Right? Now find the resultant force. Therefore, resultant force. Yeah. F is equal to, since observe in the diagram, these two forces are acting in the same direction, we can add them. When the two forces are in same direction, just add them. When they are in opposite direction, okay, you have to subtract. Now I can add these two forces to get the net force of the resultant force. That is F12 plus F23. Yeah, add the values. The F12 is 337.5 into 10 power minus 3. F23 is 211 into 10 power minus 3. Therefore, F is equal to 548.5 into 10 power minus 3 Newton. So this is the net force acting on the charge minus 3 coulomb. Where it is minus 3 coulomb, it is at the middle. Net force acting on the middle charge. Yeah, this is the next problem. ABC is an equilateral triangle of side 0.03 meter. Okay. Sides are same. Charges of plus 5 nanocoulomb, plus 3 nanocoulomb and minus 5 are placed at the corners ABC. Find the resultant force on the charge placed at B. Very important. Is an equilateral triangle first. Okay. Let's draw an equilateral triangle. Okay. Consider it is an equilateral triangle here. And there are 3 charges are placed at each corner. And here is a charge of plus 5 nanocoulomb. And here minus 5 nanocoulomb. And here it is plus 3 nanocoulomb. Plus 3 nanocoulomb. Observe here, we have to find the resultant force on this plus 3 nanocoulomb. Okay. So your sides are same, 0.03 only on each side. So since it is an equilateral, all the angles are 60 degree only. Okay. Now, as we know that for the positive charge, the electric field lines of forces going outward. See, for this, I can write the force acting outward. So this I can call it as a F1. And here is a force for the negative charge, it goes inward. You studied in the properties of electric field lines. Okay, so since here is a negative charge -5 nanocoulomb, it is coming inward. Then the resultant force comes in between. This is the resultant force line. Got it? So, and this resultant force acts with an angle 120 degree. So this is not given in data, but you have to understand this. Understand? Because when they said equilateral triangle inside, okay, the inside is a 60 degree, then the exterior angle will be 120 degree. Now there are the forces F1 and F2. Okay. First find out F1 and F2, then you have to find the F. So I'll call this forces as a Q1. This is the Q1. I'll take this as a Q2 and this is a Q3. I'll name the points as A and this is B and this is C. Okay, first I'll find the F1, apply the force between Q1 and Q2 divided by the distance. Now it is AB square. It is 9 into 10 power 9. Q1 value 5 nanocoulomb. Q2 value 3 nanocoulomb. AB square, the side, it is 0.03 whole square. So solve for this. After solving, we are getting 15 into 10 power minus 5 Newton. Okay, so this is the F1. And similarly, observe the magnitude for the force 2 relevant to the charge Q2 and Q3. The numbers are same, 5 and 3 only. Okay, since we are using the magnitude of charges, the number again 5 and 3 are same. Again, we get the same answer for the F2 also. F2 also 15 into 10 power minus 5 Newton. Okay. Now we have to find the resultant force. Therefore, resultant force F is equal to, the formula is like this, F1 square, F2 square plus 2F1 F2 cos theta. See, the resultant angle is 120 degree. Theta is 120, cos 120 becomes minus 1 by 2. Okay. Therefore, since here F1 is equal to F2, both are equal, I can write here as a F1 square plus I will write F2 as a F1 square, 2F1 into F1 cos 120 minus 1 by 2. Therefore, F is equal to 2F1 square. See here, the 2 and 2 will be cancelled out, minus F1 square it becomes. Therefore, F is equal to F1 square. Square and square will get cancelled, we'll get F1 value. Therefore, the resultant force also 15 into 10 power minus 5 Newton. So here is the problem. A little different problem it is. Okay, so the given shape is a square, right? Four equal point charges, each 20 microcoulomb, are placed on the four corners of a square of side 0.6 meter. Calculate the force on any one of the charges. Okay, let's draw a picture for that first. Yeah. Yes, I drawn a square and all the four corners has an equal amount of charge as they said, right? So here there are four charges, 4 point charges. So I'll name them point as a A, and here is a B, and this is C, and here is a D. And at the point A, all the charges are same, right? So all are having same charges only, 20 microcoulomb, 20 microcoulomb only. Okay, better mention 20 microcoulomb, 20 microcoulomb, 20 microcoulomb. Again, here also it is 20 microcoulomb. What we have to find? Force on any one of the corners. Okay. So suppose if I take the reference as a D, okay. So observe what are the forces acting on it. So it experiences the force from the charge A first, right, which is the neighboring charge. So there is a force. This is, I call it as a FA. This is the force acting on the D from the neighboring charge A. And there's a one more force from the C also, okay, which goes perpendicularly like this. This is FC. And there is a one more force which acts along the diagonal, right? That is from the charge B along the diagonal, right? This is the force acts here. This is an FB. But one more thing you have to notice that along the diagonal, along this point, okay? So here there is a one more force that is a resultant of the FA and FC. The resultant of FA and FC also lies on the same line. So I can write here resultant of FAC. Because when the two vectors goes in two different directions, the resultant comes in between, right? As we drawn here, see here, these are the two forces. The resultant force came in between, right? The same way here. Okay, so you can observe here the total resultant force. I can write that as, therefore, the net resultant force is the sum of these two, FB plus FAC. So I should find all of this. FR is equal to FB plus, yeah, how can we write the FAC? FAC is nothing but FA square plus FC square plus 2 FA cos theta. This is the formula to find out the resultant. Observe between the FC and FA, the angle is 90 degree, right? So here cos 90, it becomes 0. When you say cos 90, the value is 0. So this term is eliminated. Therefore, FR is equal to, okay, and observe the FA and FC value. Since magnitudes are same, the FA, what it gives FA, the same value comes for the FC. The same type we solve now here. We got F1 and F2 are equal because the magnitude values are same here from each end. The same way here, magnitudes are same along the AD and along the CD, the forces are equal. FB plus, I can write this as a FA square plus, I'll write FC also as a FA square. Since FA is equal to FC, you can write. Both are same. That we can find out later. Therefore, FR is equal to FB plus, yeah, solve this one, you'll get root 2 times the FA. Okay, now this is our formula. So there we have to substitute the values. Now what are the requirement? Now we have to find the FB. FB means this is the force acting along the diagonal. Okay, so what is the east side here? East side is 0.6 centimeter meter. Every side 0.6 meter it is. Then how you find the diagonal length? The diagonal of the square we can find out as a root 2 into side it is. Root 2 into 0.6 meter. This is the distance between the charge B and D. Okay. While finding the FB, use the coulombs law and substitute this distance. Okay. And finding the FA. Then substitute here. Then you get the resultant. Yes, let's do that. To find FA. FA is equal to 1 by 4 pi epsilon naught. So it is QA and the charge QD. Both are same. Divided by AD square is the distance. So it is 9 into 10 power 9 into QA. All the charges are same, right? 20 into 10 power minus 6. D also 20 into 10 power minus 6. Whole divided by AD square. Each side it is 0.6 whole square. Meter it is. 0.6 whole square. Solve for this. Get the FA value. 3600 into 10 power minus 3 whole divided by 0.36. Therefore, FA value becomes, after solving this, we get 10 Newton. Okay. And you can write in a bracket. Therefore, FC also 10 Newton. That also comes 10 only. And now we have to find the FB. To find FB. Yeah. Finding out the FB that is acting along the diagonal 1 by 4 pi epsilon naught. The charge at B and the charge at D both are same. And the distance I have to take now here, the BD square, the diagonal length. Substitute the values 9 into 10 power 9 into the charges are same here. 20 into 10 power minus 6, 20 into 10 power minus 6, and the distance is BD square, that is root 2 into 0.6 whole square. Therefore, FB 3600 into 10 power minus 3 whole divided by, solve for this, root 2 into 0.6 and that whole square will get 0.72. Okay, after solving this, we get the FV value as a 5000 into 10 power minus 3. So that is equal to 5 Newton. Now substitute in the resultant formula in this equation. Fr is equal to Fb plus root 2 Fa. Okay, let it be the equation 1 or else. Therefore, the equation 1 becomes the F resultant is equal to Fb plus, what is that equation? Root 2 times the Fa. 5 Newton plus root 2 into 10 Newton Fa. Yeah, calculate and find the F resultant. We'll get 5 plus Root 2 is 1.414 into 10, 14.14 we get. Therefore, F resultant is equal to 15, 5 plus 14. So totally it comes as a 19.142. This is the result. Yes. Let's solve this problem. So 4-point charges, they given the charge values A, B, C, and D are located at the corners of a square of side A 10 centimeter. What is the force on the charge of 1 microcoulomb placed at the center of a square? Okay. Again, it is a square shaped. So 4 charges are placed. So I'm placing the 4 charges at the 4 corners. And this is 2 microcoulomb, right? QA. And here minus 5 microcoulomb. And again 2 microcoulomb. And again minus 5 microcoulomb. I can call this as A, B, C, and D points. And the question is that what is the net force, right? Acting at a charge 1 microcoulomb placed at the center of the square. Yeah, let's draw the two diagonals so that we can find out exactly the center of the square. So here is the center. Here 1 microcoulomb charge is placed. Now what is the net force experienced by this? That we have to find. Yeah. Observe, since the charge A is positive, right? A is positive, it gives the electric field lines radially outward, right? Here the FA comes, and along the same diagonal, the charge C is present. Even this is also positively charged, okay? Then the force on this is going like this. So this is from the FC, radially outward forces. And for the negative charges, observe from the B end, here is a negative charge and the 1 microcoulomb is a positive charge. So there is an attraction, right? So attractive force it is. This I can call it as a FB. And here towards the minus 5 microcoulomb, it is FD. So you can see here all are equal in magnitudes and the net force along the diagonals are opposite in direction, equal and opposite. Along the two diagonals you can observe. The force are equal and opposite. So those forces are acting along the 1 microcoulomb charges. So mathematically we have to prove, but directly we can say that the net force is 0 on them. Because when two equal and opposite forces acting on them, the net force will become 0. But we have to prove it mathematically. So do that. The total side, each side is given 10 centimeter, right? Then what is the diagonal length? I'll call this as a O, okay? The intersection point and the charge 1 microcoulomb point it is. The diagonal length is AC or BD is equal to root 2 into side. Root 2 into side, that is 10 centimeter. But the measurement from center to each corner, that is OA, OB, OC, and OD, that is equal to half of the diagonal, right? This is a diagonal measurement for a diagonal length it is. Now I am finding the distance of each corner from the center. Divide it by 2. Then it gives 10 by root 2. Okay. So or 5 root 2 we can see. 5 root 2 centimeter. This is 5 root 2 centimeter. I'm converting into meter as a 10 power minus 3. Now first find out the force Fa by using the Coulomb's law. Here is the two charges, right? Like 2 and 1 microcoulomb. I'll call it as a FeO better. Okay. So 1 by 4 pi epsilon naught charge at A and charge at the O divided by the AO square, ROA square. It is 9 into 10 power 9 into QA 2 microcoulomb into QO 1 microcoulomb whole divided by AO, that is the OA value is 5 root 2 into 10 power minus 2 the whole square. Okay, so that I get FAO as a, solve this one, we get 3.6 Newton. This is from the corner A on the charge O, the FAO. And similarly, if I solve from the corner C on the charge O, okay, I can call it as a FCO, right? The force FCO or FC, okay, that also comes as 3.6 Newton. This is along the CO. And now find out the FB and FD. See, equal and opposite both are. Find out the FB. Here it comes 9 into 10 power 9. That BO it is, the charge B, 5 into 10 power minus 6, and at the center 1 into 10 power minus 6, and the distance from center to corner, it is same, 5 root 2 10 power minus 2 whole square. Yeah, after solving this, you get 9 Newton. This is the FB value. Similarly, we get FD also same. Okay. Or you can call it as FDO and BO. So this is also 9 Newton you get. Okay. From the figure, it is clear that F A is equal to minus FC and F B is equal to minus FD. Okay, this is nothing but FD, right? This is the FD. Therefore, the net force F is equal to FA minus FC plus FB minus FD. Those are the forces which are going in opposite direction. We are taking negative. Okay. Therefore, after substituting the values, it becomes 3.6 minus 3.6 plus 9 minus 9. So the net force at the center is 0.